Alright everyone, we are into our last section here for astronomy, which is the Earth, Sun, and Moon system.
Our moon is one of the largest moons in the solar system. It's, for the size of the Earth, it is the largest moon comparatively. Yeah, it's about a quarter of the size. For its size, it's also further from the Earth than most moons are from their planet. And it turns out it's composed of the same material that the Earth is.
So what does it mean to be a moon? A moon just really means something that orbits another body. So we've seen satellites orbiting the Earth. We could call those moons of Earth, but our moon, we call it special because it's rock possibly made from our planet. So when we look out into space, we see our planet and it's spinning on its axis once per day, but right behind us, the closest object to us and the farthest we've ever been as humanity is this rock right here. What's one of the features you notice when you look out at the moon?
Well, the first thing I notice is that it has a lot of holes, craters all over it.
So what would make one of these impact craters?
Well, you'd think maybe something from space maybe smashed into it.
So in the early formation, when the planets were pulling together and the moon was pulling together and creating their spheres, we can see that the leftover bits just rain down on the Earth and on the moon.
Yeah, and we can also kind of look at the moon and notice that it still has these craters, so that says something about its atmosphere, or lack thereof.
So the Earth probably went through a heavy bombardment period just like this, but it's very hard to find the craters here on our planet. And once that newer surface was hot and at impact created lots of heat, there could be molten lava on the surface of the moon. So those regions that look dark on the moon could be evidence of ancient lava flows.
Yeah, a long time ago there were scientists like Galileo who were trying to look at the moon, and they saw these things as being water, and so they called them seas. They're called maria, these dark areas that are filled with lava from those flows.
So there's evidence there was possibly volcanism. Maybe the moon had an active volcanic surface at one time, but after a long time that activity has calmed down. And when we look at the moon, another thing you said besides those dark patches is these craters. One of the largest is the Tycho crater down on the bottom of the moon as seen from the northern hemisphere. It's at the South Pole, and you can see it's about 85 kilometers across.
If you take a closer look at this, you can see the ejecta patterns from where the impact occurred, and it threw material from beneath the surface outward and created these things called rays.
So when an impactor comes in and hits, all that kinetic energy has to turn into something. It turns into heat, and it sends out all that material, as you can see, in all directions, creating that hole that's left behind. Since it liquefies some of the rock underneath, just like a water droplet hitting water and splashing back up, the rock actually splashes back up in the middle of a lot of craters, forming that little dimple there, like you can see here in the middle of the Tycho crater. How do you get a little mountain in the middle of a crater? It's because that entire surface was liquefied and was splashing back up. So does the Earth have craters?
Sure, it does have craters, but most of them have been eroded by the atmosphere. There is one big one, though, however.
So over here in Arizona, in a desert region where there's not a lot of weathering, not a lot of wind, we can see that the features are still there. This impact happened about 50,000 years ago and left about a mile-wide scar.
That's a big rock hitting.
An even bigger rock and an even bigger crater that took us a while to find is near the top of the Yucatan Peninsula. That's near the top of kind of the boot of Central America. And half of the crater rim is at the top of the peninsula, while the rest of the crater is sitting in the ocean. So a lot of people want to know, how did the moon actually get there? And we've got a couple different ways of thinking about that.
Yeah, there are a lot of different theories, but we're going to focus on 3 of them to give you guys a taste.
So the first one is the capture theory. In the capture theory, the moon was just another rock that was around, forming about the same time as the Earth, and just got captured in Earth's gravity. We think that actually happened with Mars. Mars has 2 moons compared to our 1 moon, but their moons are really, really small. Phobos and Deimos are these really, really tiny moons that orbit very close to Mars, and they don't look like our moon at all. They actually look more potato-shaped, and we think that maybe they were just asteroids that wandered too close to Mars and got captured in Mars's orbit. They're actually on a declining orbit and eventually will crash into the planet.
The second theory is called simultaneous formation, which says what it is, that the moon and the Earth were formed from the same materials at the same time. Problem with this theory is that if that's really true, the moon should not be made of only the materials that the Earth's crust is made of. It should be made of all of the same materials. And it turns out that the moon is made of what the Earth's crust is made of, which brings up theory number 3.
And impact theory is kind of more the most fun theory of how the moon actually got here, is that Earth was actually a little bit bigger when it was just forming. So it was being bombarded by many, many different objects, and a Mars-sized object, something about half the size of our planet, hit Earth. Earth survived, and that large object ripped the outer layer of Earth off and threw it out into space.
Right. Things were still kind of molten, so they could still form back into a sphere again from the rotation that was occurring. And so you end up with two spherical objects made of basically the same materials orbiting.
And the materials that made up the surface that was ripped off of Earth were mainly basaltic rock, the rock we find on our oceans. And that's a lot of the rock that we brought back from the moon.
Right. So most people think that this is probably the most viable theory, at least scientists do, because there are holes in the capture theory as well.
So when you take a look at the moon, just think about all the different ways the moon may have got there, all the impacts that it's had to deal with during its early formation and even today, and quite possibly the best place for us to take off and explore the rest of our solar system.
Yeah, it's a good jumping point.
And we'll talk about the way we see the moon and all the other features of it in our next ones. See ya.